Okay, in this lesson, let's talk about field force. In the field force, it's very simple, but you have to practice it. In the field force, it means you can create all of these forces with one and combine them. As you can see, all of the forces from attractor to the wind are for changing the direction, changing the velocity of the particles. They are doing this, okay? So with the field force, if you select it, as you can see, if you go to the object, here we have a field object here. It means you can control the particles with the shape of all of these fields, with the power of all of these fields. So it's all about changing the velocity and direction of the particles. Okay, let's talk about and begin with. As you can see, if you insert the field force, it's an empty box. So we are going to first create a emitter, and in emitter size, double the size in millimeter to fit the exactly. Okay, so first bring the field forces here to define its properties. In a field force, you can control the shape with a vector. You see it. First thing that I want to explain is a solid. Here is a solid. Solid, as I said before, it is just changing the direction. What happened here? What happened in this box? This is visual display of the field force that you can create it here. You can display it or change the size of this box. You can change line density if you want. So just density to see it better. Or here you can change the vector length by brightness if you want, or the length. Here you can define the length of that. I will explain them more if you face to complex scene. So go to the object. This isn't solid. It means with the solid, this is the first. With the solid, you can change the direction. One, in a y-axis, it means the vectors are going to the y-axis. What happens if the emitters hit this field force? As you can see, they are going up. So with the solid, we create a wind. With the solid, we create a wind. It's very simple. Let's change the properties of the emitter to emit more. 1000. Very huge number. And the change stop emission, nice. Lifetime, nice. Let's try it. And increase the number of the frame. Nice. So as you can see, the direction of the vector in the field force define the direction of the emitters. But another tab we have here is a field. Don't confuse it. In this object, you can use a field for define the direction of these vectors, all of this here for changing the direction. We talk about the velocity type, add the velocity, set value or change direction. But another thing that we have, it's another field. In this tab, we can define the area of the effect of that. Because we select nothing, it means the area of the effect of this vector that is going up is infinite. So we want to create a field area exactly with a box that if the particle reach this box, then the vector going up. As you can see, we have a fall off. As you can see, the length of this vector from the small going to the higher number. This is all about, you can define the fall off here is at 0. It means any particle hit this area, because of we selected fall off of that, as you can see, they are not going up. And if they reach there, they're going up. Nice. You can change the direction of this by changing that. It's very simple. For example, you want to go to the negative, you can go to the -1. As you can see, the direction of the particle and the color will be changed. And if the particle reach going down, you can combine the direction. As you can see, the direction is going in this way with a solid. So you learn solid for changing the direction of your particle. This is solid. Nice. Okay, we need the fall off. Just delete the solid. Okay. For distance and velocity, let's try another field force with a different situation that you can better understand it. Instead of emitting the emitters part on the particles, we are going to set the speed at a 0. It means they are birthing in their position like this. Nice. And we can better study the behavior of the field force to better understanding it. The field force. Okay, the field force is as you can see, it's a 3D. You can make it a 2D. You go to the display and make the Z direction a 0 to make it a 0. Here you can go to the object, and another interesting thing that you selected is a random. It's a random. Go over to the random field. As you can see, we have a direction that we explain it more. And we have an animation. I will explain. Okay. As you can see, we have a few fields here that you can go to the force, change the strength of them here. I will explain it. Going to the display and density. You can increase the density of line like this. As you can see, because of the random, we have the random direction of the vectors. These vectors defining the direction of the emitter that will be birthing. So with the randomness, we random the position, the direction of the emitters. So I can turn off the random visually to better see that. If you play it, as you can see, our emitter are going in the 3D direction for emitting in a random. This is all about the random. So you can reach all of the setting of the random. You can change the animation. As you can see, if you play it, we have as you can see, we have an animation of the vectors. It means you can change the vector. This is an emitter. It means you can add a tracer to the, add an object to that, do lots of things. Okay, this isn't just random. Another example that you can assign it there, you can delete it in the field force, in the object. You can give a volume object to control something. If you assign object here, for example, a sphere field, as you can see, you can control the movement of the particle with a sphere object, all of the objects. What happened here if you play it? As you can see, it works like an attractor. Interesting. So all of the shapes are using here are for repelling, pushing apart particles, or attracting them. It's very easy. That you can select it and change it to the direction, use a value, or another thing here. As you can see, you can change the different lengths of that, or no remap. So we need to use a value of that. Yeah, you can change the scale of that, as you can see. or here you can change the fall off, and you can move it. As you can see, we can create an interesting, crazy things, because we are controlling the shape of the emitters with sphere objects. In here, in this part, if you insert any of the fields, they are controlling the shape of the emitter. In here, you can control the fall off of that. You can control the shape of the area of affecting. So don't worry, I will explain it step by step, and I give you more example to understanding all of its settings. Let's insert, for example, in a circle here. It's very simple. Circle. Nice. Drag and drop in the object. In this field is circle. It means, as I said, explained before, it changing the shape when you insert something here. All objects that insert here, all changing the direction of the vectors. In here, it means if you play it, as you can see, the particles are going from the beginning of the curve to the end of that with this radius here. As you can see, they are rotating. Nice. You can go to the circle. You learned it before. It's very easy. Here you can change the offset. I explained them before. What is distance mode, align the curve. You can refer to the previous lesson. As you can see, they are rotating because, as I said before, in any spline, we have a start and the end of the curve. And based on that, this shape are changing the vector direction. The vector direction shows here, as you can see. And it means the particles, if you're bursting, are rotating. So you can create a rotation. As you can see, it's complete in 2D because of our particles in 2D, the rotation. Okay, now you can see main difference between the velocity type here. It means add to velocity. Velocity, it means, okay, if you turn the field force off, as you can see, our particle just birthing and creating, does not have any movement. If you set the type of the field force to the velocity, it means, okay, I give the particle a speed if they are zero speed in your sitting here. As you can see in the sitting, we have zero speed. The field force in add velocity tell you, okay, I give a speed to your particle and I move them. Add to velocity, it means your particle has an acceleration. As you can see, let's turn it on. They have an acceleration. They are going fast and fast and fast. As you can see, this is add to velocity. But if you can change strengths of that here. If you set the absolute value, it means it's give just this constant number, and the speed of, as you can see, the speed of if you change the strengths, you can visually you can see the strengths of the line. It means they have more strengths. And as you can see, the speed of the particle are constants, just exactly number here that you set. But if you set it on a change direction, nothing happened. As you can see, because the particles does not have any movement. It just changing the direction of that. So for that, you need to changing the direction, add a speed to that. It's very simple. For example, let's give another field force to better understanding that. First, before deleting that, explain something more. In a field force, change the add to velocity. Nice. If you select the layer, as I said before, distance mode is align. If you change it to radius, it just calculate the body of that curve as a radius, and the direction of the curves tell you what happened. The particles are attracting in this direction. As you can see, they're going, attracting, and then hitting back. Nice. Here you can change the radius of that effect. Nice. And you can create interesting. Okay, understand that? You can change the parameter and see the effects. It's by you. Okay, deleting the field force. I create another field force for 3D to better understanding. Another field force. Okay, it's in 3D. Make it here. Going to the object and assign random to that. Give the strange. You can go to the display. Make oops. You can see it visually later. It's not affecting the power of that. It's just all about the strength of that. And now, if you want to set it to just change the direction, you can set it to just to change the direction. And in this case, we need, you can, as you can see, you have to select field force. As you can see, if you set it here, because of we don't have any animation, any speed to our emitter, nothing happened. In this case, you have to go to the emitter and right click to the speed to default speed. And if the, as you can see, they are changing because the random is set on infinite. So we need a follow. It means, okay, if the particle reach to this area, then change them, the direction of them. Go to the field force, the field, yeah, box. Nice. You can change the box, you turn it to follow. And then, as you can see, when they reach here, they're changing its direction. Or you can change the fall off to, oh, sorry. Where is the fall off? Go to the box. How you can change your fall off? Go to the box to remapping. Oh, you can change the fall off here. Let some particles absorbing more in this. As you can see, because of the fall off, they're changing the direction of that. So if you change the field force in the object to change the direction, it means you can change the direction of that. For better seeing that, you can assign a linear to that. Let's create a linear. As you can see, we can change the direction of the particles are in this direction. If you set it, oh, as you can see, it's changing the direction. The field force is changing direction. And it's changing the direction of the field in this mode. And interesting part here is if you go to the linear, to go to the rotation, and as you can see, you can change, oh, this isn't fall. We have to change the field force, select it. And as you can see, you can change the direction of your, in this direction. Nice. If they reach here, there will be change. Just, it's for changing direction. As you can see, you can change the direction. Or give the randomness. Okay, it's very easy. Now you learn the difference between changing the direction and add the velocity. I give another field force and go into the display, make it a 0 and set the speed of that to the 0. Nice. Okay, they're just birthing and birthing to the lifetime, end of the lifetime. Another thing that you can insert here is a volume. It's very simple. For example, box. Make a box, make it smaller. You can select it, an object, and X-ray to see the inside of that. Better seeing that. And we use this volume, this intersection with this part, or if you have the 3D, it does not very important difference, because I want to explain it simpler, I set it to the 2D. This is our 3D volume, and in between intersection of that, we have some field force here. To control any direction, just click and drag the volume here, and no, sorry, I have to set to add velocity, and go to the field force in a box, in a layer, because we set it to the point, we have no point here to intersect that. Select the volume or select the surface, and as you can see, it's create a surface. With this shape, with this surface, we change the direction of, as you can see, the direction of the vectors. And exactly in this area, we have nowhere in other areas. So what happens if you birthing the particles that are attracting or repelling just by this area? If you insert any shape, it's attracting or repelling or pushing apart the particle inside or out. And as you can see, the inside of that, we have this such effect, and you can animate anything that you want. Nice. I imagine interesting more that you can do with that. Interesting. So this is the basic of the field force. And in the next lessons, let's give you interesting ideas and example to better understanding the field force. It is very more complex. You can do a lot of interesting things with that, but one by one. Hello, my friends. To continue these tutorials on YouTube, subscribe us, like us, and hit the bell icon. And now you will be alerted about all of the amazing videos that we release.